Welcome to Unit 3, Two Variable Statistics, Lesson 8, Using the Correlation Coefficient. If you could take just a moment, hit the subscribe button so that you get notification every time I release a video. And if you could give this video a thumbs up to help other people find this information and get this help as well, I would greatly appreciate it. Our learning goal today is to look closer at correlation coefficients. In the previous lesson, we talked about what those correlation coefficients are, and now we want to take a more in-depth look at these correlation coefficients. We have two learning targets for this lesson. As we are going through the practice problems, these are the things you need to keep in mind. And if at the end of this lesson you don't feel comfortable making either one of these statements, then please reach out and ask for further clarification so that I can help you be prepared before we move forward to Lesson 10. The first learning target, I can describe the strength of a relationship between two variables. You want to be able to look at the correlation coefficient and determine whether that relationship has a strong correlation, a moderate correlation, or a weak correlation. Learning target number 2, I can use technology to find the correlation coefficient and explain what the value tells me about a linear model in everyday language. You can use something like the Desmos.com calculator, have it calculate your correlation coefficient, and then use that correlation coefficient to decide whether you have a strong correlation, a moderate correlation, or a weak correlation, as well as a positive correlation or a negative correlation. Again, on the glossary terms, we have this correlation coefficient. Correlation coefficient will always be a number somewhere between -1 and 1. 1 would describe a perfect positive correlation. Your dot plot or your scatter plot is perfectly in a straight line, 45 degrees upwards from left to right. A -1 correlation coefficient would be your scatter plot forming a perfectly straight line downward at a 45-degree angle, left to right. And 0 would be your weakest correlation. In this one, we would actually see the scatter plot all over the place, left to right, kind of looking like a cloud of dots. The closer you are to a 1 or a -1, the stronger your correlation. The closer you are to that 0, the weaker your correlation. So down at the bottom, it shows these 3 examples. The first picture on the left would be a strong correlation, a strong positive correlation, somewhere close to a +1. The relationship in the middle would be a moderate to weak positive correlation, closer to the 0 than the 1. And the one on the right would be a strong negative correlation somewhere close to a -1. If you have any questions about these, please make sure to ask for clarification. Here we see a negative relationship. A relationship between two numerical variables is negative if an increase in the data for one variable tends to be paired with a decrease in the data for the other variable. In other words, here we see that as the x variable increases, the y variable decreases. We see this downward slope from left to right, so we have a negative relationship. Now we can see the positive relationship. A relationship between two numerical variables is positive if an increase in the data for one variable tends to be paired with an increase in the data for the other variable. In other words, here in this example, we can see that as the x value increases, the y value also increases, resulting in this upward slope from left to right. Here we have strong relationship. A relationship between two numerical variables is strong if the data is tightly clustered around the best fit line. So the more this scatter plot looks like a straight line, the stronger that relationship is. Next, we have weak relationship. A relationship between two numerical variables is weak if the data is loosely spread around the best fit line. You can see here these scatter plot points are spread out more, and they're starting to look more like a cloud. We can still see that it's following this general trend upward from left to right, but it's looking less and less like a line of dots and more like a cloud of dots. Now we can begin looking at the practice problems for Unit 3, Lesson 8. The first practice problem says the number of hours worked X and the total dollars earned Y have a strong positive relationship. Explain what it means to have a strong positive relationship in this situation. So, strong means the points are closely clustered around the line of best fit. Positive means that as X increases, then Y also increases. To explain what the strong positive relationship means in the context of this situation, we would say something like, as the number of hours worked increases, the total dollars earned also increases, and the relationship is closely modeled by a linear relationship. So this sums up what we were saying, but it uses the context of this specific situation. A strong relationship always means that they are closely clustered around the line. A positive relationship always means that X and Y are both increasing. But in order to explain it in relation to this specific situation, we need to mention things like the number of hours worked increasing and the total dollars earned increasing. That takes it from a general description to a specific description that is talking about this specific situation rather than just some overall generalized model. If you have any questions about how to answer a question like this, please ask for further clarification, whether that's in class with me or if you're watching online, go ahead and submit a comment and I can try to give you further clarification if you need it. The next practice problem is going to ask us the exact opposite of what the first practice problem asked us. It says the number of minutes on the phone and the customer satisfaction rating have a weak negative relationship. Explain what it means to have a weak negative relationship in this context. So first, let's explain that a weak relationship means points are scattered and not modeled well by a linear model. Then we have negative. And a negative relationship means as X increases, Y decreases. This is a general trend downward from left to right. Now, we need to take these individual general descriptions and we need to turn them into an explanation of what it means in this specific instance. So we would say, as the number of minutes on the phone increases, the customer satisfaction rating tends to decrease but these results are not fit well by a linear model. This description takes the generic individual descriptions of weak and negative, and it applies the specific things we're talking about in this context, specifically the number of minutes on the phone, specifically the customer satisfaction rating, and then combining what it means to have a weak relationship and what it means to have a negative relationship. So if you need any further clarification on how to describe weak and negative relationships in the context of a specific situation, please ask for further clarification, whether that's in class with me or by leaving a comment on the video. Our next practice problem says technology required. Use a graphing calculator to answer the questions. Question number 1 asks, what is an equation of the line of best fit? And question number 2 asks, what is the value of the correlation coefficient? So, as previous videos, anytime I see technology required, I'm going to be using the Desmos.com graphing calculator. So, what you're going to do is you're going to recreate this table on the left in the Desmos calculator. To do that, you're going to go to desmos.com/calculator. You're going to click on this plus icon that says Add Item, and you're going to choose Table. And it's going to give you a blank table with an X1 column and a Y1 column. And to save time, I've gone ahead and I've filled in the values from the practice problem. Then, if you look over here, you can see where it plotted the scatter plot. Now, what we're going to do is we are going to click over here on the left where it says Add Regression. It kind of looks like a scatter plot with a line of best fit going through it. When you click on that, notice it defaulted to a linear regression, which is what we want, a line of best fit. And you can see that line of best fit right here in blue. Now, if you scroll down, the first thing it's going to give you is the equation itself. So we're going to have y equals, looking at our table, everything is either a whole number or it has 1 decimal point. So I'm going to round to 1 decimal point. So let's say y equals 1.3 because the 5 tells us to round the 2 up to a 3. So y equals 1.3x and then we see the b, which is minus 2.8 because the 9 tells us to round the 7 up to an 8. So minus 2.8. And this is the equation for the line of best fit. Now, number 2 wants to know what is the value of the correlation coefficient. Well, if you look below the equation, you have statistics on the left and residuals on the right. Now, what we are interested in is this lowercase r. That is the correlation coefficient. So this is 0.9554. And if you remember, being closer to a 1 means your linear model fits this scatter plot data very well. This is a strong correlation. And because we can see that it is going up from left to right, we would consider this a strong positive correlation. If you have any questions about how to use the Desmos.com graphing calculator to create your scatter plot, to have it create the line of best fit, how to find the equation for that line of best fit, or how to identify the value of the correlation coefficient, please ask for further clarification. If you're in my class, please use class time to get the help you need. If you're just watching this video from somewhere else, you can leave a comment and I'll get back to you with better clarification. Our last practice problem for Lesson 8. Elena collects data to investigate the relationship between the number of bananas she buys at the store, X, and the total cost of the bananas, Y. Which value for the correlation coefficient is most likely to match a line of best fit of the form y equals mx plus b for this situation? So we have to think about what we're looking at. We're looking at the number of bananas she buys, and that's going to be X, and total cost of the bananas, and that's going to be Y. So what we would expect is that as we buy more bananas, X increases. And as we buy more bananas, the total cost increases, which means Y increases. This is a strong positive correlation. All right. Bananas are a specific price per pound. Every time you buy another pound, it goes up by that amount of money. Bananas are not all exactly the same, but they're usually pretty close to the same size and the same weight. So if we know this is a positive correlation, we know we can get rid of A and B. Those are negative correlations. Now we just have to decide whether the answer is C or D. C could be seen as a moderate correlation. So we'll say these two were negative. This one is moderate. So I wouldn't choose that one. I would choose answer D because I want a strong positive correlation. If you have any questions about how to solve a practice problem like this one, where they are giving you a description of a situation and you need to be able to critically think about what information you have and what kind of a correlation relationship you would have, then please ask for further clarification. If you're in class with me, use class time. If you're watching this video from somewhere else, please leave a comment and I will get back to you with further clarification.